So at this point, you should already know how to pull out a GCF. You should already know how to factor a standard form quadratic when the a value is 1. I hope you guys remember you do the setup, the parentheses with the x, and then you simply think what times what is c, that if you combine together is b. And I also say make a list. That's my tip to you. Make a list on the what times what is c. And we should also know how to factor perfect square binomials and trinomials by applying a square root. So this class opener activity / practice is for you guys to start this class, the first 10, 15 minutes of it. However, there are some, like let me do the first one here. You want to factor. It is a quadratic trinomial where the a value is 1, so you are able to set this up. Parenthesis, 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 x, x. And what do I say? What times what is c? That if I combine together is b. And my advice is always to make a list, right? How could you get negative 64? You could go negative 1 times 64, or negative 2 times 32. Negative 3 is not going to work. Negative 4 times 16, I believe, gives us negative 64. Negative 5 won't work. Negative 6 does not work. Negative 7 doesn't work. Negative 8 times 8. So those are all the possible ways of multiplying two numbers to give us that c value of negative 64. So it's always what times what is c that if I combine together is b. So once I have my list, I could go back and start combining. 64 take away 1, that's 63. That's not 63. 32 take away 2 is 30. That's not 30. This gives me a 12. That's not 12. This gives me 0. That's not 0. What the heck? What do?
Change the sign.
You can't even change signs. No solution. Well, this is not even, I heard you guys say no solution. That's a good, whenever you're stuck on an equation that you're trying to solve, then you would say it doesn't have an answer. You would say no solution. But right here, we're trying to factor, and we're not able to factor it. So what do we say? We say not factorable. What does that mean? That you're not able to factor it. It's just, you can't do it. You're not able to factor it, right? And we also, you could even factor a number. You guys done factor trees, right? Like if I told you, go ahead and make a factor tree of the number 24. What could you break that down to? 4 times 6, okay, 4 times 6. And this one, 3 times 2. And the 4 breaks down to 2 times 2, right? That's a factor tree right there. Notice the word factor, right? You're breaking it down. You're rewriting the number with multiplication. But there are some numbers, like if I told you factor 17, do a factor tree on 17, you can't. And right there, that's what we call a prime number. Prime. Prime also means that you can't break it down with multiplication. You can't factor it. So if I ask you to factor something and you can't do it because it's not possible, you say not factorable. You could also say prime, I guess. Prime. But I prefer not factorable, that you're not able to factor it, okay? So I want you guys to try some of these, go through, do all those. I want to jump around. Let me go to number 7. Why would I go to number 7? What's special about that one? The x squared is not by itself. There's a 9 right in front of it. So we cannot set up the parenthesis, 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 xx. You can't do that. Okay? So let's not do that. What do? Well, we learned this method called factoring perfect square binomials and trinomials, right? If you have a perfect square term in the front and a perfect square term in the back, you might be able to square root them and then plug them into your answer format. So what is the square root of 9x squared? 3 with an x, okay? So you put the 3x as the first term on both of those binomials. What's the square root of 1? 1, right? 1 times 1 is 1. And now think about this, guys. Remember, factoring is a reverse distributive property. If I were to distribute, I should get this answer. So my final step on distributing should be 1 times 1 to give me 1, right? Or it could also be negative 1 times negative 1 to give me a positive 1. They either both have to be positives or both have to be negatives. What signs do you guys think based on this middle term? This middle term is a negative 18. So negatives, right? So you're going to have a negative there and a negative there. Now you're supposed to double check it and make sure that it works, okay? So let's actually double check it. How do you double check? Just distribute. If I go 3x times 3x, what do I get? 9x squared. Okay, when I go 3x times negative 1, what do I get? Negative 3x. Okay. And then when I go negative 1 times 3x, what do I get? Negative 3x. And when I go negative 1 times negative 1? Positive 1. So when I combine the middle terms, negative 3x and negative 3x, does it give me this middle term of negative 18x? It does not. So this is not right. Okay, so what do we put right there? Not factorable. That's right, not factorable. So as you can see, we're doing some of the same stuff we were doing before on this class opener, but there's more. Well, there's a not factorable situation that we didn't have last week. Number 8. That's a perfect square binomial. So we might be able to set this up. What's the square root of 4x squared? 2x. What's the square root of 25? 5. So you have a 2x and a 5, a 2x and a 5. So if you were to distribute at the very end, you would want this 5 times that 5 to give us a negative 25. So what signs do I need right here? One has to be negative, one has to be positive. It doesn't matter which one you put where. One negative, one positive. Now, if we were to double check this, it will work. Okay? I love the difference of two squares. I love perfect square binomials when you have a minus sign, because the middle term's not there, and if one's positive and one's negative, the middle term will cancel out. It will be 0. So, I mean, I could double check this, but all right, I might as well show you. Why not? Let me double check it. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x, that's positive 10x. 5 times negative 5 is negative 25. And of course, the middle terms really do cancel out, and you do end up with what you started with. So this is the factored form of 4x squared minus 25. Any questions? Now, if you had a perfect square binomial, it has to be a minus sign for the middle term to cancel out, because that way you'd get one positive, one minus, which would cancel out. If you end up with like something like number 10, that has a plus sign. So right there, it's not going to work, right? A lot of students make this mistake. They see number 10 and they jump right into it and say, oh, the square root of 49 is 7 with an x. The square root of 25 is 5. So you have a 7x and a 5, 7x and a 5. But what signs would these have to be in order for it to be 5 times what to give me a positive 25? They'd either have to both be positives or both be negatives, but the middle term will not cancel out if you have the same sign. So at this point, what do we say? Not factorable, right? Not factorable. If you happen to put prime, I could accept that also, prime. Okay, but I prefer not factorable. Okie doke. So be careful with those. What about number 12? What could you do there? You don't have perfect square terms in the front. In the back you do, but it's not a perfect square trinomial. What could he do? GCF, absolutely. The very first type of factoring that we learned is factoring out the greatest common factor. What is the GCF right here? X squared. So pull out that x squared, and what would you have left over on the inside? X squared times what gets you that x to the 5th? X to the 3rd, okay. And then x squared times what gets us a negative 2x to the 3rd? A minus 2 with an x, right? And then last but not least, x squared times what gets us a negative 4x squared? Negative 4. And now you're supposed to look at the inside, this blue quadratic. It's not a quadratic, it's a cubic, power of 3. So we cannot do anything further. If this would have been a power of 2, then I could have continued to do this if it would have been a power of 2. But it's not. So that's all I could do. That's my answer. That's my factored form right there. Any questions? Now, if we look at this next one, number 13, that one's fun. That's definitely a huge, nasty polynomial, and we could pull out a GCF as well. Okay, what would that GCF be?
4.
6, 4, 3, 2, 8. 8?
No, wait, no.
No?
No.
Yeah, so if you're thinking 8, that's fine, but look, 12 divided by 8 doesn't work.
4.
This one does, this one does, but yeah, okay, 4 works. 4 works, 12 divided by 4, 16 divided by 4, 8 divided by 4, 24 divided by 4, all of them work with 4, so definitely 4 is the coefficient of our GCF. How about x's?
4.
X to the 4th. Yeah, we could pull out a maximum of 4 x's out of every term at the same time. So let's do reverse distributive property here. 4x to the 4th times what would get us the 12x to the 9th? 3x to the 5th. That's right. How about the second term? 4x to the 4th times what will get us the negative 16x to the 7th? Minus 4x to the 3rd, right? Because 4 times 4 will get us to 16, or 4 times negative 4 will get us to negative 16. 4 times, or x to the 4th times x to the 3rd will add together to give us x to the 7th. How about that next term? Negative 2x squared, great. And how about the last term? Plus 6, no x's, perfect. That wasn't too bad, was it? No. Now, if we look at this next one, and you're like, oh, I'm going to pull out the GCF. Okay, could I pull out an x from every single term? No. Could I pull out a 4 from every single term? No. So dang, we're stuck. We're stuck because we still have not covered factoring by grouping, and that's what we're going to cover today. That's why right above this question, it says, see notes on factoring by grouping before doing the problem below. And here's another one. If I asked you to factor this one, well, what could you do for sure? You could at least pull out the GCF of what?
3.
Of 3. If you pull out that 3, what would be left? 6x squared plus 5x minus 4. Yay? Yeah. Now, normally I would look at the inside and try to continue factoring, but I can't right now because we haven't discussed how to factor a quadratic trinomial with the a value being 6, right? Now, if this 6 wasn't there, yeah, you'd be able to do parenthesis, x, think what times what is negative 4 that if I add together is positive 5. But there's this a value of 6, and that's throwing us off because we don't know how to factor standard form quadratics when the a value is not 1. So we need to go to our notes and find out how to factor by grouping. And we also need to go to our notes and find out how to factor quadratic trinomials when the a value is not 1. Okay, so let's actually turn to our notes from last week. Here they are. Now we've already done this entire left column, and we're going to jump to this top right column where it says factoring by grouping. Okay, so I do believe for the sake of not making a ridiculously long video, I'm going to start another video just with this factoring by grouping. But please go back and finish that class opener on your own time. And I'll post the answers later on at Moto so you can check them. So the class opener completion, that's going to be part of your homework. And also these notes, completing these notes are going to be part of your homework. So we're not actually getting a homework per se, but I do want you to complete what you have right now as homework. So I'll start up another video right here on factoring by grouping.